Welcome to Module 1, Lesson 19, Comparison Shopping. After today, I'd like you to be able to solve problems by analyzing different unit rates given in tables and analyzing them using different unit rates given in equations and when given different unit rates in graphs. So we're going to look at these three situations or these three things, and we're going to learn how to pull the unit rate out of each of them and use it to do some comparison shopping or just comparing. All right, so first we have the ratio of the cups of red paint to blue paint. And again, we want to make sure to highlight correctly. So, get my highlighter here. There we go. And I have blue paint to red paint is 1 to 2, which means that for every cup of blue paint, there are 2 cups of red paint. Okay, and then the equation would also be that red is equal to 2 times blue, or that R is equal to 2 times B, where R represents the number of cups of red paint and B represents the number of cups of blue paint. So then what I'd like you to do now is I would like you to fill out a ratio table with this information, and then we're going to use that to work with our unit rates. So go ahead and pause and fill out your table, and when you come back, we'll check your answer. All right, so we should have found that with 1 cup of blue paint, there are 2 cups of red paint. With 2 cups of blue paint, there are 4 cups of red paint, and 3 to 6, and then 4 to 8. So now here, if we look at the table, I want to know what is the unit rate for this problem. Okay, so in this case, if I'm using the table, when I look at the table, I look for the spot that has one thing compared to 1. So if I look at the amount of blue paint, I see that there is a point where there is 1 cup of blue paint. Since there is 1 cup of blue paint, I can use that as my unit rate, and I know that for every 1 cup of blue paint, there are 2 cups of red paint. So my unit rate here would be 2, because it's 2 cups of red per every 1 cup of blue. Then if I look at the equation, you'll notice that here I also see that there's a 2. We know from previous lessons that that is also the value of our ratio, and we also know from previous lessons that the value of our ratio is also our unit rate. So it would make sense that our unit rate can be found right here. It's the number that we're multiplying by, that constant, to find our answers. So in this case, our unit rate we can just say is 2. So to find the unit rate in a table, you find where it is compared to 1, and then you know that that would be your unit rate. And then to find it in an equation, you look for the number or that constant that you're multiplying by. All right, so if you look here, we have Miss Sipple, who is a librarian who really enjoys reading. She can read 3/4 of a book in 1 day. This relationship can be represented by an equation. The days are equal to 3/4 times the number of books, which can also be written as D is equal to 3/4 times B, where D represents the number of days and B represents the number of books. Okay, so again, we're going to fill out a table. We're going to use that equation to fill out a table. So if I have 1 day, I know that since it's 3/4 of the book in 1 day, I know that 1 day I will read, or Miss Sipple will read 3/4 of a book. So then I know that if in 2 days, so if I double the time, I should double the amount of books that she read. So we would take 3/4 and multiply it by 2, which we would put over 1, and we would get 6 over 4. And we could change this. 4 goes into 6 once, so this would be 4 2/4, which is equal to 1 1/2. So in 2 days, she can read 1.5 books. Go ahead and try the next 2 on your own, and when you come back, we'll check your answers. All right, so you should have found that in 3 days, she can read 2 1/4 books, and in 4 days, she can read 12 force books, which is equal to 3 books. All right, so now let's get into an actual problem here. So we have Brian and Shanice who are training for a bike race, and they want to compare who rides his or her bike at a faster rate. Okay, so compare who rides his or her bike at a faster rate. Both bikers use apps on their phones to record the time and distance of their bike rides. Brian's app keeps track of his route on a table, which you see here, and Shanice's app presents the information in a graph, which you see here. So here's their information, and now what we want to know is at what rate does each biker travel? Well, let's look at Shanice first. We know that this is Shanice because it is the graph on the coordinate plane. So what I will do here is to find the unit rate, I go over to my number of hours because when I look at rate of speed, it's distance compared to time. And since this is the bottom row, that's typically what we use first. So I look and I see, okay, well in 1 hour, how far did she go? And I see here that my dot, so I follow it up to the dot, or I follow it up to my graph, and then I follow that over. And I can see here that it's halfway between 10 and 20. Well, since there are 10 units between 10 and 20, and I only want half of that, I know that it was only 5 units. So she rides 15 miles in 1 hour. Okay, and then for Brian, what we can do is we can use a double number line to show the relationship. Okay, and you see here that they don't give us, in the table, they don't give us the value for 1 hour, so we have to find it. So on top I'm going to put miles, and on bottom I'm going to put hours, and I know that if he goes 75 miles, it'll take him 3 hours. And I want to know how far will he go in 1 hour. Well here, so between 0 and 3 is 1. And that's, so there's 3 units. So we went 1/3 of the way to go from between 0 and 3, we went 1 out of 3 units. So here, this x has to be 1/3 of the way between 0 and 75. So we take the 75, we multiply it by 1/3, and we end up with 75 over 3. And we know that this is a division problem, and that we get 25. So in this case, in 1 hour, Brian rides 25 miles. Okay. Now, we can also look at this and say, well, we just ended up using division, so couldn't we just set up the rate and use division? We could. We could set up the rate as 75 to 3, and then I know that I only want the rate for 1 hour, so I divide both the top and the bottom by 3, and I would get 25 over 1. Same thing, just a different way of looking at it and working it out. Okay, and when it asks you to explain how you arrived at your answer, you can talk about how you use the double number line or division, or if you use the graph. You're just explaining what you did. So I went over to 1 hour, I followed it up till it hit the graph, then I crossed over to miles and found that it matched up with 15 miles, so my rate is 15 miles per hour. All right, so now we're going to take a look at this and say that Shanice wants to win the bike race. And since she wants to win the bike race, her speed needs to be faster. So we're going to make a new graph to show the speed that Shanice would have to ride her bike in order to beat Brian. So show the speed to beat Brian. So the first thing we need to know is, well, what's Brian's speed? Well, we know that Brian's speed was 25 miles in 1 hour. So her speed has to be greater than that. So in 1 hour, she needs to go more than 25 miles. Well, let's think of something that's easy to work with that's around 25 miles. I know that 30 is larger than 25, so I can set up my graph to show her going 30 miles in 1 hour. So what I can do here is I can set it up and count by 15, so 15, 30, 45, it's my number of miles, remember, 60, 75, 90, 105, 120, and I'm going to stop there. And then our number of hours, 1 hour, 2 hours, 3 hours, 4 hours, 5 hours. And we don't have to keep going here because it's following a consistent pattern. But remember, since I didn't skip any going this way, I can't skip any going this way. So I know that I want her speed to be 30 miles in 1 hour. So when I get to 1 hour, I should be up at 30 miles. Well, if I double my time, it should double my distance. So there should be my next plot, and I can keep plotting points here just by using multiplication. So if I take my time times 4, then I should take my miles times 4. 3 times 4 is 12. So in 4 hours, she would go 120 miles. Okay, and then now what I can do is I can make a line that'll go through all of these points, showing that it's a consistent rate. And in order for this to be correct, it also has to go through 0, 0. It has to go through what we call the origin. Okay, so, and I need a line to show that it would continue at this rate. So now this graph shows Shanice winning the race because she's going faster than Brian's previous rate of 25 miles per hour. All right, so now we have Claire and Kate who are entering the cup stacking contest, which is not important. Both girls have the same strategy, stack the cups at a constant rate so that they don't slow down at the end of the race. And while practicing, they keep track of their progress, shown here. So here's Claire's, here's Kate's. Claire's is once again a graph, and Kate's is an equation. Okay, so here T represents time, and I have C representing the number of cups. All right, so we want to know at what rate does each girl stack her cups during the lesson. Again, the rate, you're looking for that unit rate. So here we can look and see that in 1 second, Claire stacked 5 cups because we follow 1 and we follow it over to 5. So on a graph, you're always looking for where that bottom number, where that x value is 1, and then what it matches up with, and that's your rate. So Claire can stack 5 cups in 1 second. Now Kate, we have an equation. I'm going to write the equation a little bit bigger here. Now we said before, when we looked at an equation, that the unit rate was the number that we're multiplying by, that constant, which is also the value of the ratio. So in this case, we know that the unit rate here is 4. What this means is, so we can look at this as if we put in 1 for t. So in 1 second, oops, I probably shouldn't write t again. I should probably write 1 in there because that's what I wanted to multiply by. So in 1 second, how many cups can she stack? Well, I do 4 times 1 is 4. So C is equal to 4. So in 1 second, according to her equation, because I plugged in 1 for seconds, Kate can stack 4 cups. So her unit rate is 4 cups per second, which is exactly what this number is here. It was 4. So here the unit rate is 5, and here it is 4. Notice it matches the number right here, but you can always double check by plugging 1 in for your number and seeing what you get. Okay, so now Kate notices that she is not stacking her cups fast enough. What would Kate's equation look like if she wanted to stack cups faster than Claire? Okay, so what would Kate's equation look like if she wanted to stack cups faster than Claire? And my goodness, that is difficult to read, so I'm going to lighten that up a little bit. There we go. Okay, and I know we haven't really been writing sentences here, and that's okay for these since we're just kind of giving rates, and we're giving 2 rates, but typically, unless I tell you otherwise, make sure that you are writing your sentences. Okay, so her equation would need to be, if she wants to be faster than Claire, then if Claire stacks at a rate of 5, her answer needs to be bigger than 5. So what that means is the C would be the same and the T would be the same. We're still going to multiply the unit rate by T to find the number of cups. But in this case, if we put 5 in, she's not going to be faster than Claire because if you notice, if we put 2 in for T, we do 5 times 2, which is 10. Well, we're going to get these same numbers. 3 times 5 is 15. 4 times 5 is 20. So putting in a 5 won't work. We need to put in a number bigger than 5, which here we could put in 6. Yeah. I want you to come up with a different equation that would allow Kate to go faster. So I gave you this one as an example. I want you to write an example of an equation that would allow her to go faster than Claire. Remember, this is your unit rate, and you want it to be faster than Kate's, which is 5. All right, so what I wanted you to get from this lesson was that for each of the different types of problems we're looking at, so the equation and the graph and a table, that you can find the unit rate. Please make sure that you know how to find the unit rate, and if you do not, make sure to ask in class so that way we can go over it. Also make sure that you give me a different equation for Kate so that way she has a faster speed. And make sure that if you have any other questions, you write them down so we can go over them in class.